Hey everybody, I'm back. You may have noticed I haven't published any content in the last month or so, and that is because I have been super insanely busy, particularly with one job that just absolutely kicks my butt. Some of you may have heard me talk about this big job that I'm working on. It's a total of a little over 2,000 pieces. And this first batch that I had to deliver was a little over 600 pieces. And those 600 pieces absolutely did me in. It was so much more work than I expected, and a lot of it went rather poorly. This is what my mill looks like right now, and I think that's a pretty good indicator of what life was like. Utterly buried. I didn't record much during that project because, well, frankly, a production job is not that interesting to show. But also, I was so far behind that I just did not have the time for it. Or frankly, the energy for it. I think there is a lot to learn from the project, and I have been taking notes. So I have a couple pages here of what I'm calling my after action review. And I will share that with you guys so that hopefully we can learn something together. So let's start with the things that generally went pretty well. The first thing that I think generally went pretty well was my inspection process. I had that pretty much dialed in from the beginning, and it proved to be reliable. I checked at least some features on every single part that came off the mill. I didn't check all the features on all the parts, but I checked at least some features on all the parts, and on a couple parts I checked, every feature, 100% inspection on, a certain sample of parts. But for the in-process stuff, the in-process inspection, I made some of these gauge pin sets. So on these, it's a 3D printed holder with a go and a no-go pin. And I made these for a couple different features. I was able to use these pins to hit at least most of the critical features. Some I did have to use calipers to measure, but a large percentage of the model I was able to use these pins to check. Now, some of them I hadn't 3D printed the handy little holder yet, and I just had them taped together. But this process works super well. Additionally, I made a drawing for Op1, Op2, and Op3 with the critical dimensions I needed to check with calipers after every operation. I didn't catch a single defect in one of my 100% inspections, and I think that is because I was able to catch them all during my in-process inspections. Another thing that worked super well was the Tormach. The 1500 absolutely killed it for this job. The 1500 processed more than 2,500 pounds of steel in about 3 weeks. I averaged a spindle on time, like an actual program running time of 8.5 hours per day over the last 3 weeks. And I only had one maintenance issue, and that was a screw came loose in my ATC that I just had to put back in. It took me maybe 15 minutes, was not a problem at all. This thing just worked. I didn't have any problems with it. It cut great the entire time. It was super, super repeatable. The tool wear was definitely far more noticeable than any potential inaccuracies in the machine. This thing did fantastic. It was a beast working through these parts. Now, you may notice there are a few chips in the machine right now. Most of that is my fault, but we'll get to chip management later. I'm putting that in its own category in this video. Some other things the Tormach did really well is they added some new probing cycles, and one of them happened to be exactly what I needed to set up the Workholding that I'm using, so that was really nice. Thank you, Tormach, for adding new features. It's also super quick and easy to probe in work coordinate systems because it's just like a single button press up here. And then also touching off tools and changing those out was really, really fast and easy because PathPilot is just so well done compared to even like the Haas controller, which is generally considered one of the easiest to use controllers. So I have absolutely no complaints about the 1500 throughout this entire process. Wait, no, that's actually not true. I made one improvement to this machine. So this up here is like the stack light. This will be green when it's running a program, it turns off when it's not running a program, and it's red if there is an error. It is very difficult to see the color of this like clear acrylic thing when the LEDs from underneath turn on. And so I added a little piece of acrylic mirror up here to the top at a 45-degree angle, and that lets me more clearly see what color the stack light is. Here, can we turn it on? All right, so the E stopped on and now it's blue. If you look at the color of the acrylic, it's very hard to see, especially under that light that's right there. But if you look in the mirror, the color of those LEDs is very clear. So that is one little change that I made to it. I might 3D print something to make it a little bit more pretty, but having that worked really well, especially when I was over across the room at my saw. That was the one upgrade I made to the mill to make this project work. But another thing that went really well on this project is this Wise camera. I originally had this sitting down here, but it was hard to see what was going on in the mill. So I just hot glued that sucker straight to the window. And that let me pull up a view inside the machine, both on my computer and on my phone at any time, which really helped me just monitor the machine to make sure that it was running and let me know when the cycle was done and I needed to come and change out parts. So that camera, big win. I very much enjoyed having that. And in fact, I have added a second camera up there that'll let me see both the Tormach and the Haas at the same time. And I have a third camera that I'm going to put on the saw. Another thing that I thought went really well was how I packaged the parts. Mailing 615 parts is not a small task, but the customer suggested that I use these egg crates, and they were absolutely right. Because I had these egg crates, I didn't have to like individually wrap them in styrofoam or anything. What I did is I bought these 12 by 12 by 12 boxes that perfectly fit the egg crates, and then I would load it up with parts and then clamshell another egg crate over the top of it like that, and then pack those into the box. I could do 3 layers of 30 parts, put some brown paper, and nothing could move everywhere. There was no rattles or anything. That worked really well. It's a little bit buried with my brand new 3D printer and its various accessories, but also having a nice, well put together shipping station, again, made shipping the job much easier. And then lastly, I would say just my overall process was pretty good, at least by the time I was done with the parts. There was a little bit of tweaking in between. For the second half of the part, so for about 315 of them, I was able to use a single piece flow process, and that really shortened the loop on how I was able to dial in my fixturing and my work holding and my program to get it more reliable and making better parts. My program was generally pretty good. There wasn't a lot of wasted time in it. There were some tooling and speeds and feeds issues, which we will get to, but for the most part, what I had programmed in CAM from the beginning was very, very close to what I actually ran in production. A lot of the features, especially in Op1, were very consistent and very reliable. There was a tight tolerance hole that, except for like one part where I had a chip get on the taper of the tool holder, I never had any scrapped. And I never had any accuracy issues between features that were done in the same operation. Now, where I ran into accuracy issues was when I was switching between like Op1 and Op2 and features that had their critical tolerances straddling different operations. I had a lot of issues in those cases, but we'll get there. So we just talked about everything that went smoothly, that went really well on this project. Let's talk about the things that were a little bit mixed. And to start with, we need to talk about the saw. I bought all of the material in 12-foot bars. I did not buy it pre-cut. And I just brought it in through this door here, slid it onto this little slidey saw table, and then cut it on the Tormach saw. Most of the time, I cut 4 bars at a time, so I had like 4 wide. So every time the saw cut, I got 4 pieces done. The pieces, which looked like this, would then fall into one of these black bins, and I use these bins as Kanbans. So I would be cutting into one, I would be pulling from the other one at the machine, and then when the one at the machine got low, I would swap them and kind of keep flowing through. Now, this is an auto saw. It can auto feed, but I was not using that feature. And that is because I broke it. Pretty early on into having the saw, I broke a sensor and I just hadn't gotten around to replacing it. And so I've been running this in manual mode. When I was doing like the kind of more small batch and prototyping stuff, it didn't really bother me. I definitely should have fixed that before this job, and I will fix it before running it again. What I did do instead is I 3D printed this little guy. So this says 1.9 on it. That means 1.9 inches. And when I was loading material, I would just stick out the material by this amount. So I would pull it through, and then I push this against the blade, and that would give me my cut length, so I wasn't like trying to measure anything. And this worked super well. It gave me a very consistent length, and it didn't require any fiddling. I also 3D printed this little go, no-go gauge here. So you can see on the right there's an X, that's my no-go, and this bin, or this side here, is my go. So once the parts were cut, I could set them in here, and it would need to fit inside my go, but not fit inside my no-go. I didn't check every part that came off the saw with it, but every once in a while I would just make sure that my process was still working, and that did work really well. In terms of the saw itself, I didn't have any reliability issues. I did break a blade at one point, but I replaced that and it was fine. It cut very straight, and well, it was repeatable as I am with that little 3D printed length setter, but no mechanical problems with the saw, except for one thing. I realized that down there is a little drain that goes to the coolant tank. That drain is supposed to have a strainer on it, but I do not have that strainer, so all of these little chips would go and clog up the coolant return tube, and then eventually it would spill on the floor. I bought this saw used, and I just didn't know it was missing that part. I didn't even realize it was supposed to have a strainer there until I started running into issues. So I need to either make or buy a new little chip strainer so that the coolant line doesn't clog up, so that it's able to drain and it doesn't spill on the floor. Earlier on, I did have some issues with some like splashing from this coolant line making its way onto the floor, but I just added this piece of plastic here that is cut and glued into an L shape, and it has some pieces of stock sitting on there to weigh it down, and that cured basically 100% of my splashing issues. Another problem I had, which this isn't really a problem with the saw, more of a problem with my shop, but if I was in my office over there or at the machine, with the machine running, you can't hear if the saw is running or not, and I would end up leaving the saw for long periods of time sitting idle because I didn't know that it was done with its cut. So in the future, I'm going to put a camera on this saw so I can, from inside my office, just tell when it's done, and I can come out here and start a new batch of material. So chip management. That was maybe one of the bigger problems I had during this job. And if you look in the machine, you can see at the end of the job, I wasn't doing so well. And there's a couple of reasons behind that. So the reason I'm putting this in the mixed category instead of the complete fail category is most of the time the mill did really well. If you stay on top of it, the washdown does a good job of removing the chips. But there was a couple problems that I ran into. First problem was where to put the chips. So when I started off, I had like 2 trash cans and 1 or 2 of those clear bins. And that was fine until I was filling those up like every single day. I eventually ran out of places to put chips. And so I turned off the washdown in my program, and I just let chips build up in here. And I let them build up, and I let them build up, and I let them build up until it became like, I never had issues, but it was clear that it was going to start being a problem soon. And when that happened, I went and I bought a whole lot of bins. And I just started filling these bins up. I eventually ran out of room in these and started putting them in trash bags. And I just ended up with boxes of chips all over my shop. And because I was so far behind on this job, I just had no time to stop and go drop off the chips at the scrap yard. And so I just kind of let chips build up. And you know, I got to the point where I was stealing trash cans from around the shop to put chips into. And eventually, by the time we got to the end of the project, I just let them build up in the machine again. There's probably 2 or 3 bins worth in there that I get to clean out now. So the washdown in the machine works as long as you turn it on. And if you turn it off to keep chips from building up, then it becomes a little bit more annoying to clean out the machine. I ended up making this guy, which I'm gonna put in the win category. This is a piece of like 2020 aluminum extrusion that I 3D printed a little like rake head for. And this is the perfect size to push chips down the little chip chute. So this was a big win. I also have a shorter version with a handle on it that's a little bit more ergonomic, and this is better for like raking chips back here. Another thing that I want to do in the future is add a camera probably up there looking down at the chip bins, because one of the problems I ran into is that if you let a little mountain of chips build up back there, you can end up with a traffic jam, a log jam back into your machine, which will prevent the washdown from working, and you'll have to like manually clear out the chips again. Another problem with chip management is around my work holding here, I just constantly had piles of chips building up. And because of the tubes here and the hold downs that I'm using, it was very hard to clean this off between cycles. Frankly, it just wasn't worth the time because it would just build up the next cycle. Now let's talk about some of the things that went poorly. To start off with, my work-life balance. It was bad. I spent a ton of time in here trying to get those parts done. Additionally, I was supposed to be done with those parts before I went back into another teaching phase, and I did not get it done in time. So I essentially was working a full like 8 to 10 hour day in here before then going and teaching for another 4 hours at the end of the day, which plus another 2.5 hours of driving to get there and back. It was a lot of very long, very frustrating, miserable days. I did not spend time with my family. I missed church for an entire month. It was a rough month, and I'm very glad that at least this portion of the job is done. I cannot have a repeat of that. And a lot of this was caused by simply not starting on the project early enough. There was a relatively short lead time on this first batch, but I could have started a week earlier, but I had other jobs and some other commitments that were pushing me longer on it, and I didn't get that buffer time. I lost all of my buffer time right at the beginning, so then I couldn't use it when I needed it. My biggest problem with this job was by far Workholding. For the majority of the job, I did the op ones in these little import vices, and this was actually fine. Not great, but fine. I had originally started with this vise, but as you can see, I broke my traditional 6-inch vise. Now, I did find out this was my fault. I was just over torquing it. So I can't really blame that on the vise. I just am part gorilla, apparently. But because I was going from this guy to this guy, I had to significantly back off my speeds and feeds and how aggressively I could cut, because this thing, it just didn't have the same rigidity that this thing did. And you can see what my actual setup looks like here. This is where I was doing op 1s, that was op 2, and then this was op 3. I wish I could show you the part, but I can't. Sorry, NDAs. The first thing you may note here is I have the little lever that is used to activate this Aroa base stuck in there. Normally it's removed, and then I have it held in place with a bolt. And that is because during heavy roughing, particularly if the tool got dull, it could actually slowly vibrate this thing open, which would promptly scrap my part and break my tool. That happened to me a couple times before I got smart enough to put that in place. That was never a problem on these pneumatic bases, though I did have to lower my speeds and feeds compared to what I would have in like a big old 6-inch vise. My op 3 work holding was perfectly adequate. I never had any issues with this, with the exception of a burr that could show up on the bottom of the part. If I didn't remove that before putting it in op 3, that would cause me some accuracy issues. But op 2 was the cause of a large portion of my problems with this job. The part kind of looks like that Z-shaped Tetris piece where it kind of goes over and then up and then over again. And in op 2, I'm having to cut on the end of the part that's overhanging. So I'm holding it from a little thin portion on the bottom right, but then I'm removing material on the top left. That put a lot of weird forces on the part. In some parts of the program, I believe the tool was trying to pull the part like that and kind of lever it up. And in other parts of the program, it was trying to kind of push it down like that. And plus, because it was overhanging there and unsupported, it was vibrating more than it should have been, in addition to this not being the most rigid vise and setup of all time. And I could only hang on to just a little bit here on the bottom of the part. I think those vibrations and those weird forces caused these soft jaws to break down relatively quickly. Those soft jaws would break down, which would both cause accuracy issues, and then also the part would move on me. And it would either just move and scrap the part, or it would move, scrap the part, and break my tool. And in fact, I scrapped an embarrassing number of parts on this job. Like probably more parts than I've scrapped in the entire rest of my machining career, especially by weight. It was bad. I probably wasted about 16 hours of machine time making scrap parts. And most of that was due to the Op2 work holding. I eventually learned that reskimming the jaws every now and then made a big difference because it would like get rid of that wallpaper. Because this is a self-centering device, you can actually skim both the front and back wall, and it'll still put the part in the same place because it'll just recenter it. Eventually, I figured out that when I made the jaws, if I clamped 3 of these little shims in there, these are 1/16 inch just aluminum sacrificial shims. If I clamped 3 of them in there when I first made the jaws, then as the jaws started to wear out, I could just reclamp it with 2 and then reclamp it with 1 and just get several cuts out of the same pair of soft jaws that would give me nice fresh surfaces that would extend the amount of time that I could use that pair before having to start from scratch. If I had been smart, I probably would have figured out how long I could go between reskims, but I didn't. And basically I would just wait until a part came loose and either just scrap the part or scrap the part and broke the tool. And then I would reskim them. And because of that, I broke a lot of tools. I broke like a lot of tools during this job. Which leads into my next point, which is basically just tooling. So first of all, I realized far too late that if I bought a face mill, I could have both reduced cycle time and gotten better parts. There were a couple places that I was just facing off, and being able to do that with one pass on a face mill would have been a significant cycle time advantage over doing it with a smaller end mill. Plus, one of those faces had a high surface finish requirement, and it would have been much cheaper just to rotate inserts instead of throwing away a 1/2-inch end mill. But going back to the work holding, something that goes hand in hand with that is the size of the tool that I was using. Initially, starting off, I was using a 1/2-inch end mill for all of the roughing and for all of the finishing. And that combined with overly aggressive speeds and feeds, because I was in a hurry and running out of time, led to me just pushing these little 50mm Aroa bases too hard. And at one point, I broke like 4 tools in a row and I could not figure out what was going on. It turns out I'd actually damaged the little locating plates on the end here, and it was actually attempting to rotate my vise a little bit, and the tool would suck it in and it would break the tool. Eventually, I dialed back my speeds and feeds and then even switched from a 1/2-inch to a 3/8 to a 8mm tool for the roughing, and that helped a lot. But then, because I was breaking so many tools from other places, I eventually ran out of my 3/8 tools, I ran out of my 1/8-inch tools, and I started to run out of my 1/2-inch tools. And so at that point, I was just grabbing anything and everything I could from around the shop to finish up the job. It was a weekend, so even with like next day shipping, I would still be down for a couple days. So I was just in panic mode. I was in flail mode. And because I was flailing, I had so many different versions of the code. There were a couple times where I ran the 3/8-inch code with an 8mm end mill. There were a couple times where I ran the 8mm code with a 3/8-inch end mill. I was using tools with different flute counts than they were programmed with, and it just led to even more scrap. I scrapped so many parts during this job, if I hadn't made that clear. Most of it was caused by the work holding, but then the work holding caused me to break tools, which caused me to have a just chaotic process, which caused me to break more tools and make more scrap. Oh yeah, here's one of the plates that was on the vise. This is the one I had to replace. You can kind of see how it is like warped, and I don't know if it's obvious, but this here is very much like bowed out. Yeah, that's not good. So I've got about 6 weeks before I need to deliver 800 more of these parts, and I definitely want to do a better job this time around. So I have a to-do list of things that I need to put in place before that happens. So first on my list here, after cleaning, is I'm gonna use that little hole that's in my coolant tank, and I'm gonna put a coolant float in there so I can tell how much coolant is in here so it never gets low. I'm also gonna get my RO system back functional again because using tap water has caused some foaming issue. And I'm gonna find a way to plumb the RO water so it goes from the holding tank over and to either directly into the machine or to a place over here where it's easy to fill a bucket and I can just dump it into the machine. I'm also gonna try to find some sort of timer that I can put on that fill system, because I think I overfilled my bucket every single time, and there's no like drains in the shop. If I overfill a bucket, it goes onto the floor and I have to mop it up. I spent hours mopping from overfilling buckets because I got distracted while I was topping off the machine. Most important thing I can do is I'm going to replace these aluminum jaws with steel ones. And after talking to my buddy and podcast co-host Harrison, he recommended that I make them quite a bit thicker to support the part better. That alone, I think, is the biggest single improvement I can make. I'm also going to reprogram the job with standardized tools instead of this kind of jumbled mess that I have been using. And I'm going to create a tool Kanban for each of the tools that I use on this job so that I never run out. Additionally, I'm going to buy like a 1.5-inch face mill, and I'm going to buy some chip breaker roughing tools. I'm also going to 3D print or laser cut some inserts to go in my process bin and maybe add a second process bin that'll keep me more organized on things like go, no-go gauges. I'll 3D print some proper holders for the last few that I have left. And I may even make a couple more gauges just to check some more features on the part to be extra sure. We already talked about a lot of improvements for my saw. I'm going to fix the automation issue. I'm going to add a camera to it so I can make sure that it's not sitting idle. And then I'm going to add a strainer to the coolant system to make sure that it, is always flowing coolant. I'm also going to set up some sort of Kanban system for emptying my chip bins so that I never run out. I'll probably color code these into 2 different sets of bins where I'll be working on, the first set of bins. As soon as I'm out of the first set of bins, that'll be my signal to go bring them to the scrapyard. And while I'm waiting for time to do that, I can start filling up the second set of bins. And then hopefully I have the first set empty before the second set fills up. And then lastly, I'm going to look into automation for this thing. Next week is going to be Automate the 1500 week. That's been one of my big goals for this year, and it is now time to get that done. I have a couple plans, a couple things that I'm going to try out. I will experiment with those ideas next week. If that doesn't work, I'll probably just make some pallets that I can manually switch out. But my goal is to have this completely automated, or at least as much automated as I can. I don't know if this video is going to be particularly interesting or helpful to you guys, but I hope it is. There's kind of been this thing lately where starting a machine shop is like a new get-rich-quick scheme. And I don't know, you can definitely make money in it, but like all get-rich-quick schemes, it's a whole lot of work to make it work. And I don't know, there's just not enough honesty about what actually running a job shop's like in reality. And there are times where it sucks. This last month has been hard. I wish I had a normal job right now because this last month was not worth it. I hope you guys can learn from my mistakes. I really do, because nobody should have to go through this. Thank you guys for watching, and I will see you in Automation Week.